Hello everyone, I hope you are all doing well. I'm Manhar and welcome back to MSFT Fabcast. In this video, we are going to learn the steps on how to create Hyper-V Failover Cluster in Windows Server 2025. A Hyper-V Failover Cluster is a high availability solution that provides fault tolerance for virtualized environments running on Microsoft Hyper-V. It is essentially a cluster of physical servers that work together to ensure that if one server fails, the virtual machines running on that server can automatically fail over to another node in the cluster. This ensures that applications and services running on those VMs experience minimal downtime. In this configuration, the Hyper-V servers in the Hyper-V cluster have shared storage and network connectivity needed to provide compute, storage, and networking for virtual machines. In this example, we have two Windows Server 2025 Hyper-V hosts that are joined to our Active Directory domain msftwebcast.com. This is a first member server with the FQDN ws2k25-hv01.msftwebcast.com. This machine has three network adapters. One NIC is dedicated to production, the second is used for cluster communication, and the third is for iscsi storage access. This is our second member server with the FQDN ws2k25-hv02.msftwebcast.com. This machine has also three network adapters just like the first member server. The Hyper-V role has already been installed on both member servers. A cluster requires shared storage to be configured and accessible to all cluster nodes. For iscsi storage in this lab, we are using Windows Server as the iscsi target server in this example. We will use the iscsi targets and present them to our Hyper-V cluster. Step 1. Connecting to iscsi storage. Open the Run menu, type iscsi cpl and press Enter to open the iscsi initiator properties. Click Yes to start the service and set the service startup mode to automatic. Go to Discovery tab. Click on Discover Portal. Enter the IP address of the iscsi target. In our case, the IP address of iscsi target server is 192.168.72.50. The default port for iscsi is 3260. Click OK. Next, go to the Targets tab. We can see that the target is detected, but its status is inactive. Select the discovered target and click on Connect. You can select the option Add this connection to the list of favorite targets to reconnect the iscsi targets whenever the server restarts. By default, the checkbox is selected. For this demo, we are not configuring multipath I/O or adjusting the advanced options. Click OK. The status will be changed to Connected. Click OK to close the iscsi initiator properties. Let's bring the disk online and create a partition on it. Right-click on the Start menu and select Disk Management. Let me maximize the Disk Management console. A to disk appears as Unknown and Offline. They also display the size we configured on the iscsi server, such as 100 GB and 5 GB. Right-click on disk number 1 and select Online. Now right-click on disk number 2 and select Online. Right-click on disk number 2 and select Initialize Disk. Make sure both on your disk have a check mark next to them. Choose the GPT partition style and click OK. Right-click on the unallocated space of disk 1 and select the simple volume. Click Next twice. Choose a drive later to assign. Label this 100 GB volume as cluster storage. Click Next and click Finish to create a simple volume. We need to repeat the same steps for the second disk. Right-click here and select New Simple Volume. Click Next, Next, Next. Label this 5 GB volume as Quorum. Click Next and click Finish. If you want, you can change the drive later as per your requirement. Now close the Disk Management console. The storage configuration is complete on this member server. Step 2. Install the Failover Clustering feature. Open an administrative PowerShell session by right-clicking the Start button and selecting Terminal Admin. Type the command install -Windows feature -name Failover Clustering -include management tools. Press the Enter key to install the Windows Failover Clustering feature with management tools. Wait for the installation process to complete. Once the installation process is done, verify installation was successful by running get-windows feature failover-clustering command. We can confirm that the failover clustering feature is now installed on our local server. Step 3. Setting up virtual switch. Configuring virtual switches is essential for the proper network configuration of a Hyper-V failover cluster. We can use either PowerShell or Hyper-V Manager to set up the virtual switches for Hyper-V. In this example, we will use Hyper-V Manager. In the Hyper-V Manager, click on the Virtual Switch Manager option. As you can see, no virtual switch has been created on this Hyper-V server yet. Select the New Virtual Network Switch option and choose the type of virtual switch you want to create. In this example, we will create an external virtual switch as this type is necessary to enable connectivity between guest VMs and the physical network. Select the external switch type and click on Create Virtual Switch. Enter a meaningful name for the virtual switch to easily identify its purpose. Let me add name External vSwitch 01. You can also add a description, a note for the virtual switch to easily identify its purpose and reason for creation. Now, select the physical network adapter of your computer that is connected to the external network. In this example, we will select the first network adapter as the other two network adapters are linked with the cluster. Ensure that the Allow Management Operating System to share this network adapter checkbox is selected. This will enable the management OS to share the selected network adapter with the virtual switch. In this example, I'm not going to enable VLAN ID for this virtual switch. Once you are ready, click Apply to apply the settings and make them take effect. As soon as you click Apply, a warning window will appear. Be prepared for a brief loss of physical connectivity as Hyper-V disables the physical NIC, configures the virtual switch and then re-enables both. Click Yes to apply the changes. If you are connected to your Hyper-V server remotely, you will lose connectivity for a few moments during this process. After a few seconds, the RDP connection will automatically reconnect. After reconnecting, verify that the external virtual switch has been created successfully. Set up identical virtual switch names on both hosts to ensure they match, particularly when performing a live migration. Let's click OK to close Virtual Switch Manager. We need to perform the same steps on the second Hyper-V host. Let's connect to our second node using RDP connection. To save time, I have already completed most of the steps on a second node WS2K25-HV02. Only the storage configuration is pending on our second node. Open Run menu, type iscsi CPL and press Enter to open the iscsi initiator properties. Click Yes to start the service and set the service startup mode to automatic. Go to Discovery tab. Click on Discover Portal. Enter the IP address of the iscsi target. In our case, the IP address is 192.168.72.50. Click OK. Go back to Targets tab. Select the discovered target and click on Connect. Click OK. The status will change to Connected. Click OK to close iscsi initiator properties. Right-click on the Start menu and select Disk Management. Let me maximize the console. Both our disks appear as offline. Keep it offline. There's no need to bring it online. Open Hyper-V Manager. Click on Virtual Switch Manager. We have set up an external virtual switch named External vSwitch 01 which matches the name on WS2K25-HV01. Click OK and close Hyper-V Manager. Return to WS2K25-HV01. Step 4. Create the Hyper-V Failover Cluster. Now we are ready to create a Hyper-V Failover Cluster using the server nodes we have set up. We can use either the Failover Cluster Manager or Microsoft PowerShell to create the Failover Cluster. Open Server Manager. From the Tools menu, select Failover Cluster Manager. Before creating the Failover Cluster, we highly recommend validating the configuration to ensure that the hardware and settings are compatible with Failover Clustering. Make sure the entire configuration passes all validation tests. Under Management, click on Validate Configuration. On the Before You Begin page, select Next. We can use the Browse button to search Active Directory for computer names. We can also simply type the short name, fully qualified domain name, or IP address of a computer and click Add to have Failover Cluster Manager search for it. Click on Browse. Type WS2K25 and click on Check Names. Select both servers and click OK. Click OK again. Ensure that WS2K25-HV01 and WS2K25-HV02 are both added. Once done, click Next. On the Testing Options page, select Run All Tests and then select Next. On the Confirmation page, select Next. The test will begin, the progress will be displayed. This process may take several minutes depending on your network infrastructure and the number of nodes you have chosen to add to your cluster. Once the tests are complete, check the report and resolve any configuration errors. If the results indicate warnings or failures, select View Report to see the details and identify which issues need to be corrected. In our example, I think we have warning. Let's see that. Click on View Report. This will open the report in Microsoft Edge web browser. We have one warning in the System Configuration category. Click on System Configuration. This warning is related to software update levels. Click on Validate Software Updates Levels. Since both nodes are not connected to the internet, the system cannot determine the update status. We can ignore this warning. In production environment, ensure that both nodes are up to date with the latest Windows update. One more warning is there about the pending reboot. Both servers have updates applied which are pending a reboot to take effect. It is recommended to reboot the servers to complete the patching process. So we need to reboot both nodes. So let me close the cluster validation report. Let me click on Finish here as well. And let's reboot both Hyper-V servers. After reboot, we are now ready to set up a 2-node failover cluster. On Server Manager, click on Tools and select Failover Cluster Manager. Let's create a Hyper-V Failover Cluster. Under Management, click on Create Cluster. Click Next to continue. Click Browse to select the servers for creating the cluster. Type WS2K25 and click on Check Names. Select both servers and click OK. Again, click OK. Ensure that both servers are added. Once done, click Next. Enter the cluster name that you want to use to administer the cluster. The matching object that is created in Active Directory is known as the cluster's computer name object. We are going to name it HV cluster. We will be asked to choose the network to create one or more administrative access points on and to select an IP for it. We will only select the 172.18.72.0/24 network, which is our production network. Type the IP address that you want to assign to the cluster. In this example, I am assigning the IP address 172.18.72.55. Click Next to continue. On the confirmation page, review the settings. By default, Add all eligible storage to the cluster checkbox is selected. Clear this checkbox if you want to configure storage later. If checked, any LUNs that have been attached to the nodes will be automatically added as a cluster disk, with one being selected for quorum. Select Next to create the failover cluster. Wait for the cluster creation process to complete. This will only take a few seconds. Please wait while the cluster is configured. On the summary page, confirm that the failover cluster was successfully created. If there were any warnings or errors, view the summary output or select View Report to see the full report. We can confirm that 2-node Hyper-V Failover Cluster was created successfully. Let's close this report. Select Finish. Let's wait for the cluster to load properly in the Failover Cluster Manager. Let's verify that the cluster is configured correctly. Expand cluster name and navigate to Nodes. Ensure that both nodes in the cluster are online. Expand storage and click on Disk. The system detects the iscsi drives and displays them here. If you were setting this up with only 2 nodes, the 5 GB quorum disk would have been assigned as the disk witness in the quorum configuration. Click on Networks. As you can see, we have total 3 networks. This is a cluster network 1. Let's double click on cluster network 1. The 10.18.72.0/24 network is our cluster communication network, so I'll rename it to Heartbeat Network. Uncheck the Allow clients to connect through this network checkbox. Click Apply and then OK to save the settings. Let's double click on cluster network 2. The 192.168.72.0/24 network is our storage access network, so I'll rename it to Storage Network. Select Do Not Allow Cluster Network Communication on this network. Click Apply, then OK to save the settings. Let's double click on Cluster Network 3. The 172.18.72.0/24 network is our production network, so I'll rename it to Production Network. Ensure that both of these options are selected. Click Apply and then OK to save the settings. Let's double click on Heartbeat Network. I think I forget to clear the checkbox. Click Apply, OK, and OK. We have now configured a cluster network according to our network topology. Step 5. Add a disk as CSV to store virtual machine data. Even though we have shared storage from an iscsi target perspective, we must ensure that the storage housing of VMs is configured as a clustered shared volume. Expand storage and click on Disk. Click on Cluster Disk 2. Currently, this disk is mounted with the drive letter E. Let's add this disk as a cluster shared volume to store virtual machine data. Right-click on Disk 2 and select Add to Cluster Shared Volumes. Under Assigned to, verify that it now says Cluster Shared Volume. This means the disk is now designated as a cluster shared volume. Click on Disk 2. Now this disk is mounted at the path C Cluster Storage Volume 1. To verify, open File Explorer and navigate to the C drive. Open Cluster Storage and locate Volume 1. This is where the CSV is mounted. Now that we have our clustered shared volume setup, we can change our Hyper-V settings to use the clustered shared volume as the default location for storing our VMs. Step 6. Changing Hyper-V storage settings. Open Hyper-V Manager. Click on Hyper-V Settings. Under the default VHD location, click on Browse. Click on this PC, navigate to the C drive. Then access Cluster Storage and open Volume 1. Create a new folder and name it VHDX. Click on Newly Created Folder and then click on Select Folder. Click on Virtual Machines. Under the default Virtual Machines location, click on Browse. Click on this PC and navigate to the C drive. Then access Cluster Storage and open Volume 1. Again create a new folder and name it vmconfig files. Click on Newly Created Folder and then click on Select Folder. Click Apply and then OK to save the settings and close the Properties window. Perform the same steps on WS2K25-HV02. Right-click on Hyper-V Manager and select Connect to Server. Type WS2K25-HV02 and click on OK. Right-click on WS2K25-HV02 and select Hyper-V Settings. I'll go ahead and modify the default locations for the VHD files and VM configuration files. Now we can create a highly available virtual machine using this failover cluster. Step 7. Create a highly available virtual machine. Go back to Failover Cluster Manager, then click on Roles. Right-click on Roles, point to Virtual Machine, and then click New Virtual Machine. Select the target cluster node for VM creation. In this example, we'll select HV01 and click OK. Wait for a few seconds to wizard to appear. Currently, we want WS2K25-HV01 to host the virtual machine. The new virtual machine wizard appears. Select Next. Specify a name for the virtual machine such as TestVM. The VM will be stored on the CSV as we previously changed the default location. Click Next. We'll go with the Gen 2 VM. Specify the amount of memory required for the operating system that will run on this virtual machine. For example, specify 2048 MB of RAM to run Windows Server 2025 core. Also enable dynamic memory and click Next. On the Configure Networking page, connect the network adapter to the virtual switch that is associated with the physical network adapter. Select the external virtual switch and click Next. If you want to change the disk size, enter a new size for the virtual hard disk. Click Next to continue. Choose Install an operating system from a bootable CD/DVD-ROM option. Then choose Image File. Click on Browse to specify the location of the ISO image file. In this example, we will choose the Install an operating system later option. Click Next to continue. Click on Finish. Let's wait for a few seconds. The virtual machine is created. Again wait for a few seconds. The High Availability wizard in Failover Cluster Manager then automatically configures the virtual machine for high availability. Verify the success message and then click on Finish. We can see the virtual machine with the name Test VM and the current owner node is WS2K25-HV01. We can start the clustered virtual machine we configured and proceed to install the OS in the VM. I'm not going to record the steps for installing the OS in the virtual machine. At this point, we can confirm that we have successfully created a Hyper-V Failover Cluster using Windows Server 2025. We have also created a highly available virtual machine on our Failover Cluster. That's all for this video on how to create Hyper-V Failover Cluster using Windows Server 2025. I hope you found this video helpful and informative. If you have any questions or comments, feel free to leave them below. Don't forget to like and subscribe for more videos on Microsoft Hyper-V and other Microsoft related topics. Thank you for watching and I'll see you in the next video. Have a great day.